Actually, before I do that, I just want to mention this just in case you had thought about saying. So today after school, I have to go to a meeting. I am still staying after school, but it'll be after that meeting, so I'll come back up here. So if you were planning on staying after school today, just hang out up here until I get back. So that'll be around 2:45. Also, Thursday and Friday, I won't be staying after school at all. So Friday I won't be here, and Thursday I'm leaving right after class. So I will not be staying after Thursday, so if you needed me, come see me today or tomorrow after school or in the morning. So for number 1, it asks what is the zero. Remember, zero, solution, roots, x-intercepts. Those are all interchangeable words. So it's asking you for the x-intercept of number 1. To find that x-intercept, you need to put 0 in for y or f of x. Take out f of x, put in 0, and solve. So if we did that, we would need to move 4 to the other side by subtracting. Multiply by the reciprocal on both sides, so that -3/2. On the right, you get this 1x. On the left, this would become positive 12/2, which gives you positive 6. So 6 was our intercept, or 0 for number 1. This is on side 7C also. For number 2, it gave you the graph of this line, and it asked for the solution. Solution is another word for 0, x-intercept, roots. So I just wanted you to find where does this cross the x-axis, and it crosses it here at -2. Number 3, I think I said on your paper to put that in Desmos or the calculator. I'm going to show you both. Let's do Desmos first. So in Desmos, you can just type it in, or you can type in the f of x, either or. Graph it, and when you click on the graph, you can see where your x-intercepts are. It'll tell you it's at -1.5 and at 2, or -3/2 and 2. If you have your calculator with you, I'm going to show you how you would do it on the calculator. You can follow along that way. The calculator I have is kind of small and not over here. I'm in the process of trying to get a more full screen one, but I don't have that right now. So on the calculator, you would need to go into your y equals. Go into your y equals and type in your equation. So don't type in the f of x, just type in the actual equation part. After it's all typed in, you can hit graph, make sure it's there. When you hit graph, you might be able to see your x-intercepts right away. But if you wanted to make sure that you weren't guessing, or maybe it looks like it goes through 2, but you're not 100%, you can go into second trace. It's going to give you options of different things your calculator can calculate. You're looking for zeros, x-intercepts, so go into that second one. And then it asks you for a left bound. So since we're looking for 2 different zeros, I'm going to look for just one at a time. So let's say I'm looking for this one all the way over here, this one, this -1.5. A left bound of that would just be some number that is left of that 0. So I could say like -2, -3, any of these numbers. Then a little triangle is going to pop up to show me that's where I put my left bound. Then I'm going to do the same thing on the right. I don't want it to go past my other 0, but I could say like 0, because it just needs to be on the right side of that. And then you can't really see this one, but now there's 2 triangles. It's like I'm only looking in between these 2 places. Then it says guess. That's if you want to like pinpoint where it would be. You don't really want to do that. You want the calculator to do all the work so you can hit enter again. And it would tell you that that 0 is at -1.5. Then you can do the same thing with the other side. Go back, second trace, 0 again. But now I want the left bound of this 0, so I could say like 0. Right bound of that x-intercept would be something on the right side of that, so 3, 4, 5, doesn't matter. And then hit enter again, and it would tell me in between those 2 lines is a 0 at 2. So either or, you could have done it on the calculator or on Demo. Pretty sure I said skip this one or that one. Number 5, I'm going to kind of talk through, because if you were to see a problem like that, you won't, but if you were, this is kind of the process of how you would do it. So what it says is you're given 2 equations. You don't know what this value of k is. You're trying to find some value for this k, but once you know what that is, the x-intercept of both of these is the same. In order to find that, you would need to find the x-intercept of the first. So that's what this part is, finding that x-intercept. Adding 3, multiplying by the reciprocal, getting 6. Once we know that x-intercept of the first one, we know that this second one has to also have the same x-intercept. So I could put in the point 0, 6, so put 0 in for y, 6 in for x, and solve for k. Once we have that value of k, we could go back and put it back in and see if I didn't put 0 in for my h of x and didn't put in a value for x, would I still get my x-intercept of 6? And the answer to that was yes. So if you were to get something like that, solve for one of the x-intercepts, put that x-intercept into the problem, the other problem, and then double check and make sure it works.
Guys, look at where I circled on the back. Can you read that thing? Conan when press 0 as x-intercept solutions. You know anything about Conan Wimp Chris? You know who that is? It's me. That's the name people call me. Some people call me Conan. Some people call me Wimp, Popeye. Some people call me Chris. I'm the same. I know who it is. When you see zeros, x-intercepts, and solutions, same thing. You're going to see it throughout here. Zeros, x-intercepts, solutions. Same meaning, different words mean the same thing. So when you see them in questions, what are the zeros? What's the x-intercept? What are the? It's all the same thing. It's like my name. Certain people call me those names. It's still me. These are all the same.
For number 1 on the back, I think that was one I said use Desmos in the calculator. So I'll show you the answers first, and then I'll show you what that would look like on Desmos. You could have used the calculator for that one, but because those aren't color calculators, if you were to graph all of them at the same time, it would just look like lines everywhere. And you might not know which one is which. So these 3 are the answers: 2x minus 6, x squared minus 9, negative 3x squared plus 10x minus 30. On Desmos, that'll look something like this. So I have all 5 of them graphed. And I'm going to make this a little bigger. And I'm looking for which of these goes through 3 when x is 3. And only 3 of them do, the red, the blue, and the purple. The green doesn't at all, and neither does the black, so I'm going to get rid of those 2. And just focus on those 3. So those 3 were the answers to that one. I said skip number 2, but that's very similar to the one we just did, that number 5. So you could go back and try that one. Number 3 asks you to write the x and y-intercept. So remember that in this format, your y-intercept is given to you, but your x-intercept you need to solve for. So put 0 in for y, or f of x, and solve by adding 4 and then dividing by 3. So 4/3 was your x-intercept. Number 4 just asks you to circle the y-intercept on the function. So right here was your y-intercept at 0, 4. And then the last question asks which of these have exactly 1. So first, any of these that only have 1x will only have 1 x-intercept. So it's only going to go through the x and y-intercept once, x and y-axis once. But anything with 2 x's, it's iffy. It could have 2, 1, 0, or not sure. So graphing those to see them would be like your best bet for now until we figure out how to solve them. So if I graph them all, if I see one that has 2 x-intercepts, I can get rid of that one. So like this blue one has 2, and it asks for which ones have just 1. The purple one doesn't touch it at all, so that would not have any x-intercepts. The black line clearly goes through the x-axis, so that has 1 x-intercept. And the green touches it at 1 place. So they both have exactly 1. So x squared minus 6x plus 9 and negative 3 times x plus 1 were both the answers to that one. Questions on any of those? Excuse me. All right. We're going to start new notes today. Guys in the back, go back to your seats, please. Guys, sit down. Where you just at? Right, so on the first page, I have some filled in notes, so I'm going to talk through that as you're writing these down. So the first blank, we're talking about rate of change. When you hear those words, you should be thinking slope because they're the same thing. Rate of change specifically is a ratio that shows how one variable changes with respect to another. But on a graph, we call that slope. Slope is written as a ratio of the vertical change or the rise to the horizontal change or the run between any 2 points on a line. This remains constant for any 2 points on the same line. So that means whatever the slope is between point A and point B is the same between point B and point C and point D, and so on and so forth. And then slope is written as a fraction in simplest form. So yes, it is a ratio, but we want it in fraction form and also simplest form. And it's always going to be rise over run. So think about, some of you may sit straight up in bed before you actually get out of bed. So you rise before you run. That's me. I do that. The variable for slope is m. Josh, make sure you're writing this down. Preston, make sure you're writing this down.
I got it. I don't know.
There are 4 different types of slope. I'll let you go ahead and write those in. Positive, negative, 0, and undefined. We're going to graph some examples for those here in 1 second. And you still need this top part.
Me. No, it's okay. You can move on. I'll get it later.
Okay, so if we have a positive slope, if I'm reading left to right, it's going to look like this, where I'm going up and to the right. If I'm looking at it the other way, so right to left, then I'm going down and to the left. Think about up and right as positive things and down and left as negative things. If I have a negative over a negative, what am I going to get? Positive. So both ways work. For a negative, if I'm reading left to right, it's going to look like this. I'm going down and to the right. So with these, you have one thing that is negative, but the other is positive. If I'm looking at it the other way, so right to left, then I'm going up and then left. Still, just one thing is negative, one thing is positive. If we have a 0 slope, it's going to be a straight horizontal line. Anyway, so with a 0 slope, you don't have a vertical change at all, but you have some horizontal change. So you're moving left and right, but you're not moving up and down at all. And 0 over anything is going to be just 0. When you think about walking across the floor, driving on a straight road, biking, skating, whatever you do that's straight across, that would have a 0 slope. Undefined slope is a vertical straight up and down. So that one has a vertical change, but it does not have a horizontal change. Garrett, you have a calculator. Pick a number, any number, and divide it by 0. What happens? What number should you pick?
58.
Okay, 58. You put 58 divided by 0, or you did 0 divided by 58.
It says error.
Yes. So anytime we divide by 0, our calculator stops computing, stops working. We can't divide by 0. It does not work. We get undefined. But the other way, if 0 is in our numerator, then the answer will be 0.
Just real on the
Yeah.
XY axis again. The horizontal, which axis is this? What is this direction? Is that the X or Y that is? Y. The X. So this is your road again. It's like this. It said a flat road. Are you gonna live on a flat road if you're driving? Most likely, no. That's 0, right? You're flat. You're 0. The vertical. The Y, am I on this road? You can't drive on a Y. You can't drive on a cliff, right? Unless you have a special car. But so if you're up and down, you're dead, right? You're driving so it's undefined. You can't do it. X is 0, Y is undefined.
So for number 1, when we are counting the slope, look and see if there are any points plotted. Most of the time there will be, but sometimes there won't be, and it'll just be a line. But anywhere where you see the points like meeting at the grid lines exactly, like right here, you could use those points. So if I was looking at this left to right, I'm going to count how many units up or down first. It's always rise first, then run. I would go up 7. And then I'm going to the right 4. That simplifies 7 over 4. Up and right are both positive, so I end up with a positive 7/4. But let's say you did it the other way. You were reading right to left. If I started at this point, I would now need to come down before going over because it's still rise over run. It's just however way you rise up or down. So it would still be 7, but it would be a negative 7 because we're going down. And then we're going to the left 4. So that would also be a negative. So we would have a negative 7 because we're going down, and a negative 4 because we're going left. The only simplification we can do here is to make these both positive. So you would get the same answer no matter what. It's just how you look at it. Questions on number 1? Number 2, we're going to do the same thing. There are points already on here. But for this one, there are also other points. So you may have saw these ones first instead of the ones that were already there. It does not matter which points you use as long as you are counting correctly. So if I saw the dark blue points first and I was counting, to those, reading right to left, I would start at the top and go down. I'm going down 3. And then to the right, however many. So my slope would be -3 over +9. I can simplify that by dividing both of them by 3. Yes. So my slope would be -1/3. If I saw the light blue points first, and let's say I was looking at it the opposite way, right to left, same thing, we would count rise first. So I would go up 1, and then to the left 3. That is left, yeah. Even though I'm putting the negative in the denominator, that part doesn't really matter. You would still get a -1/3. And what this really means is that I could go up 1, left 3 as many times as possible, and I'll always end up at a point on the graph. Any questions so far? For number 3, I'm going to give you guys this acronym that I use to help me determine which is which. Yes. So boy is horizontal. So horizontal line is what it's really talking about. This would have a 0 slope. And later, when we get into graphing and writing equations of lines, it'll be important to know that this is a y equals equation. So for number 3, this is a horizontal line. So if you know it's a horizontal line, the slope is going to be 0. But if you wanted to count it and do that work, you could still do that. I don't have a horizontal chain at all. And I do have points here, but you could really choose any 2 points on there, count what that is. But 0 over anything is going to be 0. So you could count that, but if you know that horizontal lines have 0 slope, then you don't have to. The box part is vertical. So straight up and down. Undefined slope. And exit. So if you are given a vertical line, then it should have an undefined slope each time. And again, you could also do that work as well. So here, I see these 2 points, but again, you can choose any 2 points. Count. This goes 5 down, but does not go left or right. cannot divide by 0, we would get an error. And anytime we get an error, it's going to be undefined. I shortened it to U and D, but same thing. There are more practice problems on the very last page. Later, you can work through some of those, or maybe next class. But we're going to keep going. To this page. So finding slope from a graph, you're just counting. If you have to find slope algebraically, you're going to use this formula. y2 minus y1 over x2 minus x1. Yes. When you're doing this formula, let's say you forget which one comes first. If you happen to switch these two, so it's y1 minus y2, that's fine as long as you also switch the denominator. The 1s and the 2s need to line up. If they don't, you're going to get a negative where you're supposed to be positive or vice versa. What cannot be switched are the x's and the y's. So we can't put the x's in the numerator. They need to stay in the denominator. It's always that rise over run.
You guys see before over, if you have a slope, this is a way to think about this getting into 0 and undefined. How do you know the difference? Which one is, if you have the Fed dollar, do you feel comfortable knowing which one's a 0 slope and which one's an undefined slope? You don't have to yell out. The way I think about it, just to make it easier, is the y's are on top, right? The y values are on top. The x values are on the bottom. So if you have a y value, think of y-axis, up and down. That's undefined, right? That's the cliff, driving up and down. If you have a y value, which you do here, 4, a number, that's going to be an up and down. That's a vertical. If you have an x value, that's the bottom and a slope, right? If you have an x value, that's the axis that runs flat. So you have in this case, you will have a 0 slope. Y value up top, that's the vertical. You have an x value, that's horizontal flat road. So that's the difference between undefined and 0. You think, why aren't they both 0? I mean, but you can't have a 0. Nothing. 0 doesn't go into anything. So there's no value. So anyway, that's how I think about undefined 0. Undefined is y 0.
Do a couple
As
examples
an x
together.
value in the slope.
When I find the slope, the easiest thing for me to do is to label the x's and the y's. So remember that these are ordered pairs, x, y, x, y. So I'm going to label the first one x1, y1, and then x2, y2. Once I've labeled them, I use those to put in my formula. So the formula says y2, so look at that, and it's 3. I'm subtracting y1, which is 1, and then x2, which is 4, and I'm subtracting x1, which is 1. Then I subtract and simplify. Josh.
So basically, you can just grab one of them and put it up top down the bottom.
When you say grab one of them, which
Like,
numbers
grab
are
another
you
section like 4 and 3, and then you grab
cannot go in the numerator.
Can't go in the what?
Grab the x's can go up here. And
Yeah.
you go down here. So the order which you put them does not matter as long as you put both of them in the same order. So if I grab this one first, then I need to grab this one down here. I can't pick 2 first and then minus 1 and then 1 minus
Same
1.
line.
Right. It's okay. I have to redo the dog punch.
Go a little bit.
To subtract both. If at all possible to simplify, do that. In this case, you cannot simplify, so you would just be left with 2/3. This is just to show you that this would still work. If I switched these around and I did 1 minus 3 and then I did 1 minus 4 in the denominator, I'd have -2 and -3. And this would still become a positive 2. So as long as you're switching them both, you still get the same answer. If I only switch one, you would end up with either the wrong answer completely or the wrong answer where it's supposed to be positive, but it's negative, or vice versa. Questions on that one before we do another? Lily, did you see the packs that I brought you with? Did you see the packs that I brought you with? Okay. Yes, Josh.
So, I don't know where I got the paper from, but it's on my phone. Anyway, so on number 3 on this one, you wrote it as both 5s on top and 8 and 4 on the bottom. I wrote it the opposite way. So I put 8 plus 4 and then 8 plus 4 on top.
X's cannot go in the top. They have to go in the bottom.
Okay.
So we're going to do number 2. Same thing, label them. And then put them in the format. So even if you have negatives, you're always subtracting. So this would be -2 minus 4 all over 10 minus a -2. Make sure you include both the negative and the minus. If you put like plus minus, you're going to get something wrong. So if you know that this is going to become a plus, you could change it to that, but I wouldn't start off with that to lessen confusion. So from here, I can say this minus and this negative are going to come together and become a plus, but I wouldn't write that at the beginning. And then I can subtract -2 and 4 and add 10 and 2 and then simplify. So -6 over 12 would give me -1/2. This is equals m at the top. I just ran out of space. So always simplify if you can. We're going to do one more of these together, and it's going to be one of the ones at the bottom. So the ones with fractions are harder than anything you will actually see moving forward on examples, on the quiz, on the test, anything like that. So this is really just here so you can see it. So we'll do one. The other ones will be if you need to challenge yourself or want to challenge yourself. Because if you can do these, you can do them all. We're going to do number 7, and I'm going to write it down here. You may need extra space because it's a lot of work. So these are fractions. We're still doing it the same way. It just is going to be a lot, so we're going to take it step by step. So I'm still going to go through and I'm going to label these. And still start off using my formula. So y2, 3/4, minus y1, 2/5, all over x2, 1/3, minus 2/3. So it looks something like this so far. -1. So with these two sets of fractions, our denominator we can go ahead and combine because we have the same common denominator. So 1 minus 2, remember we're only subtracting in our numerator, so that would be a -1 over 3. And then I'm just going to leave that alone so we can focus on the top. In order to combine my top two fractions, I need to get common denominators, because I don't have that right now. So I'm looking for multiples that these share, and I think the lowest one is 20. So to get 5 to be 20, I would multiply this by 4, but what I do for one part of the fraction, I have to do for the other. To get 4 to be 20, I need to multiply that by 5, and again, I would need to multiply that to the top. So this would become 15 minus 8 all over 20, or 15 20ths minus 8 20ths. Once you have once you have common denominators, you can combine them. 15 minus 8 will give you 7 over 20. You can't simplify 7 over 20 anymore. So the only simplification we have left to do is to get this fraction out of a fraction. So in math, in general, we don't like that. Don't like the way that looks. So to get rid of that, we multiply by the reciprocal of the denominator. And because it's still one big fraction, what we do to one part, we have to do to the other. So multiplying across, we have 7 times -3 is -21. 20 times 1 is positive 20. -1 times -3 is positive 3. 3 times 1 is 3. 3 divided by 3 is 1. And -21 over 20 over 1 is just -21 over 20. So that one has a lot of steps, but the rest of those, like those with fractions, are there to challenge you. Try them if you would like a challenge. I'm going to give you the next 5 to 10 minutes to work on these 4 problems though. 3, 4, 5, and 6. If you finish those and want to try 8, 9, or 10, be my guest. But you don't have to. You have this time to work, and then we'll come back and talk about those answers. If you have questions or want to check your answer, raise your hand, we'll be around. So you can check your answers. Number 3 was 5/2, or 5 over 2. 4 was -1/3. 5 should have been 0. Make sure you're simplifying all the way. So if you got 0 over -2 or 0 over 2, make sure you simplify that further just to get 0. And 6 was undefined. Again, simplify that all the way. If you have some number over 0, 0, that should automatically be undefined.
Again, the way I look at it, if the number is in the X or the top or the bottom, is it a Y value that you're seeing, or an X value? If it's a Y, why am I going over this cliff? That's an undefined. If it's in the X value, it's a flat road. You're fine driving on a flat road. You're going to live.
Just so you guys remember, these filled-in notes are on Canvas. So if you ever miss something, they're on Canvas. Did we have questions on any of those before we move on? I did move to the next page.
Actually, even real quick, back in the time, take a picture of it. That's what I'm practicing.
Filled-in notes are on Canvas. So you can get it from Canvas. So when we have linear equations, they are written in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So when we had equations before, when we were finding x and y-intercepts, and we were looking for the y-intercept, and I said we don't need to solve for that y-intercept because it's given to us, this is why. It was actually giving us the y-intercept in that format. So this next part right here should really be with our writing equation, so we might see this part again. But just so you see how these would be written in this format, if I were given, for example, number 1, this slope and this y-intercept, how would I write the equation of the line? Right. We're just putting the slope and y-intercept together in that format. What about number 2? How would I write that? X plus 4, yes. What if I jump down to number 5?
What?
Yeah. So you could put plus 0. You could also leave it off. Either or is fine. When you see problems, you won't see that they say plus 0. If you were to get a problem like that on the quiz or test and you wrote plus 0, I would not mark it wrong. So either or. Minus 0 is also acceptable because it's not really positive or negative. For number 7, again, it's asking you to find the slope and y-intercept and then also write the equation. We're going to hold off on writing the equation, but mainly focus on the slope and y-intercept parts. So the y-intercept is easy because I'm looking out on the y-axis. Where does this cross the y-axis? At this point right here, negative 4. The slope, however, we need to count. So find 2 points. This one happens to have 2 points. Count how far you go up and then over, or if you started here and went here, how far you go down and then left. So we're going up 3 and right 1. Oh, my slope.
3 over 1.
3 over 1, or just 3. So anytime you have a whole number over 1, make sure you simplify that as much as possible. Just put 3. And again, you guys could write in this equation. I'm just not doing that at this moment. For number 8, again, the y-intercept, we could look and see where does this cross the y-axis. And then for our slope, we need to count. So I see these 2 points. We need to count rise over what would that be? 6/4, negative 6/4, but let's simplify that. Negative 3/2. So negative 6/4 is not incorrect. It is technically the slope, but we need to simplify. This simplified slope means if I go down 3 and to the right 2, I should end up at another point on the graph. Every time I go down 3 and right 2, I should end up at another point on the graph. In which I do. Alright. We're going to stop here and we're going to finish the last page next class. I do want to mention a couple things. So you have 2 delta mass on slope 1 you could do, but it's not due until Monday. So the one you could do is on finding slope from a graph and slope from 2 points. In delta math it says slope part 1. Khan Academies, you have 3 that are all due Friday. 1 is slope from a graph. 1 is slope from 2 points. The other is slope intercept intro. So that one is basically what we were just doing. It'll give you some sort of information. Can you determine which one's the slope, which one's the y-intercept, whether from a graph or from like what we were just doing. So you should be able to do those 3, but again, they're not due till Friday. You could try the slope part 1 delta math, but again, that's not due till Monday. After next class, you should be able to do slope part 2 delta math. If you need help with any of that, please come see me before or after school. Remember that I will not be after school Thursday or Friday, but anytime in the morning. And we can go through any of those problems together. If you already jumped ahead and started practicing, I can check those. Otherwise, I'm going to give you guys the rest of this time. Yes.